Okay. Good afternoon, everyone. So, have you all started the mini project? Anyone started to simulate? No one yet. Okay. So, submission on 12th January. Okay. And then for today's class, okay, so we'll go through the. So last week, what we did, we designed a schematic simulation of OPAM. So this week, we're gonna go through some layout design. Okay. So this is the contents for this week class. Okay. So we'll have a look on how to do a parametric analysis. Okay. So parametric analysis means we're gonna do some sweeping. Okay. So basically, what you have is we'll do some sweeping. Sweep. Like you set one parameter, you make it an unknown. Let's say you want to sweep the VG, you want to sweep the VDD, you want to sweep the sizes. You can set them as whatever unknown you want. Maybe VG, X, U, W, whatever you want to set, and you can tune it from one range to another. So once it's tuned and all the parameters is given, and you can plot multiple numbers of gain or pace or whatever parameter that you're looking for. Okay, so that is called parametric analysis. So next one will be creating symbol and also do a test bench. Okay, so this is we will use the same simulations. Okay, just that we will do a symbol, create a symbol from the schematic, and we'll simulate it using a test bench. Okay, so there it's a bit different than directly simulating on your schematic. So then what we will do, we will next one will be having a fundamental layout drawing. Okay, so we cannot do any verification because we don't have the license. So maybe you can start with the layout drawing first. And once the license is up on January mid, maybe you can test it out. Okay. So I want to insist that the fundamental layout drawing is a 10 marks bonus if you include it in your mini project. Okay. So you're getting a 10 marks bonus. It is not necessary. It is not compulsory to do the layout. But if you do it, you'll get a 10-mark bonus if you include in your mini project, in which your OPAM, you do a layout. Okay. So that's going to get you a 10 marks of bonus mark. Okay. So, okay, so these are some hotkeys that I included. So later I will just upload it in the e-learning or I will just share it in the WhatsApp group. Okay, for case for your schematic and your layout tool. Okay, so layout we'll just have a look later. So okay, so this is on layout. So I will explain this later. So let's start with our parametric analysis. Okay, so let's look at parametric. Okay, so basically let's go to our schematic. Okay, so this is your schematic, and we open our ADE. Okay, let's load our last session. Loop state from cell view. Okay, and we'll have our save data and all and save simulation. Okay, so for parametric, you just go to tools, select parametric analysis. Okay, and you will have this window. Before going to here, let's set, for example, so in our VP and VN, let's do a gain simulation. Okay, so for gain, we need DC, the 1 volt of AC magnitude. So for the DC voltage, I'm gonna set it as my VDC, the unknown. Yeah, I put a name there, VDC. Click OK. And also in VP, the DC 500 millivolt, we set it as VDC. Okay. Click OK. Check and save. And then go to your analog design environment. Okay. So once you're done here, at the design variables here, okay, design variables, I cannot right click there. Okay, so here, okay, let me find it. Here variables here, your variables tab, copy from cell view, and you'll have your VDC popping out there. Okay, so this value, you can assign a value. So we start with 0 first. Okay, set a value, VDC and 0. Okay, from variables copy from cell view. Okay, so whatever unknown that you are setting in your schematic, so once you set that as a variable and your copy from cell view, and all the variables will appear here. Okay, so now you have your VTC. So next what we do, we go back to our parametric analysis here. Okay, so variable name, you just type VDC, our variable. So range, we're gonna do from 0, let's say, to 1 volt. Okay, so step control, this one you can play around later. So I'm doing linear step with a step size of 0.2, let's say. Okay, so if you set 0.01, then it will go by step size of 0.1, 0.1 like that. Okay, so I'm setting 0.2. Okay, and I select this one. Okay, so next is analysis start. Okay, so it has completed successful. So 0.2 from 0 to 1. So we're gonna have about 5. Okay, so let's plot results. Annotate direct plot. AC gain. Let's start with AC gain only. Okay, AC DP10. Like nodes of turbulence. No, it's not working. Try again, plot the AC gain and phase. Okay, wait, something is wrong. Yeah, there you go. So it takes some time. So give it some time. Let me do it again. Results, direct plot, on AC gain only. Let's try again. Put and input. there. Okay. So this will help you to ease your simulation time. So you don't need to do it for every time you're simulating it one by one. You can set a parameter and it will simulate for you. So now let's check. So you can see here, right? So all these variations here. So each line shows the DC level of each values. Okay. So here this is 0 volt. This is when it's 0 volt. Just select one. Cannot. Okay. So the red one is 0 volt. Okay. So and I think this one will be, that's just one line. Okay. So you can see we swept from 0 volt up to 1 volt. Okay. So we have our 0 to 100, 400, 600, 800, and 1 volt. So for the gain, this is your gain, and I think this is, no, we have only gain. Okay. This for the input. I mean, I should plot only the output. Plot again. Results. Direct plot. So when you're plotting one by one, you only need to select one node. Just output, and then you press escape. It will plot for you. Okay, yeah, this is the correct. So this is your gain variation for all the values here. So you have 0. Okay, you cannot select it one by one. Let me separate everything. Still cannot. Okay, just some bugs. Just select everything. Okay, can see, right? So when 0 volt, this is your gain 0. As you increase 200, this is your 200 milli, and you have 400 milli. Okay, 600 milli, 800 milli, and 1 volt. So see how it varies. Okay, so gain varies from here to here for each given values of your voltage. Okay, so this is how you do your parametric simulation. Okay, so another example, let's say you want to tune a size and check the gain, so how it impacts. Okay, so for example, let's say I want to change the size of this transistor. Okay, I can select this multiplier as my X. Okay, apply it. So you can do it for your length, for your fingers, all that, but always keep in your mind the minimum and maximum value that I told you in your last class. Okay, so you shall not exceed your minimum values and also your maximum values. Okay, so now I set my multiplier into X. I can save my ADE variables, copy from cell view, and my X will pop up there. Okay, let's say now I don't want to tune my VDC. So I set my VDC. I can just put this 500 milli. I can set it here as well. Okay, so setting here is equivalent to setting it as there. Okay, so now my X, I want to sweep it from 1 to 10, let's say. So I put 1 first. Now let's go to our parametric analysis. Okay, I change here X. Okay, and I want to sweep it from 1 to 10. You can even put 100 or 50 and run all the simulation. Okay, so that depends on the power of your simulation. Okay, so step size is 1, and I want to run this one. Start. Okay. Okay, it's done. Okay, so I'm tuning my components value to get the gain. Okay, for example, now let's go into our results. Plot. And select here and escape. Let's see. Okay, so this is my variation on adjusting the size of my NHP down there. Not much at the DC sides. Okay, so the gain side is not much variation. There is slight variation, but not much. So as you can see, it's only from 20 dB to 19 dB. So it's not varying too much. Okay, so you can tune this way to find the parameter that you wanted. Okay, so you can set any of the components here as you wanted. Okay, so next one, how do you want to sweep several parameters? Okay, so you can go here, add new variable to bottom. So you'll have 2. So you can even add how much you want to. Okay, so by doing this, you can sweep 2 parameters at once. So I have my X. So just now we have our VDC. Okay, from 0 to 1 volt. Okay, and the linear steps, I put this as 0.2. Okay, also select this one. So now it will simulate 2 parameters. So it will compare for 0 VDC with all the X values, and then 0.2 VDC for all the X values, 0.4 for all the X values. So it will compare like that. Okay, so go to analysis, start. Okay, so it will generate 60 points. Okay, because it will compare each one to each. Okay, running. Okay. So when you're tuning, so you no need to do it one by one manually. So you can just set certain parameters and see whether you are getting the gain or not. Okay, so it's done. So now let's plot and see. Let's plot 10. So you will have 60 plots like this. Okay. So what each DC bias for each X values. Okay, so all of them. Now see the variation is quite huge because you're also setting your DC values together with the X values. So you are getting much more variations. Okay, so you can test, you can see this value. So I'm just not how to make it separate. So when you point here, it's supposed to show only a 1. Okay, so just try around and see. I'm still selecting everything. Okay, put a marker and try to get the what value is that. Okay. Okay, so these are the gain values. So it's rising from up to 11 dB to 20 dB. So you are having the range. So once it reach maximum, take that value. Okay. So in order to get the parameter that you wanted. Okay. So same thing. Now let's say you want to tune your capacity, you want to find the load capacitance. Okay. So how do you set this one? So let's say I want to test with my width. Okay. So I want to put my width. I put W here. Apply. See, at the length there, can you see how the equation is changed? So the model will calculate for you based on the value of the W that you're giving. Okay. You can select that, check and save. Go here, same variables, copy from cell view, and you will have your W coming out here. And this is the related equation. Okay. So here, let's start with 1 micro. Okay. Go to your parameter analysis, and you can add another one. Setup, add new variable to bottom. And here we have W from 1 micro to, let's say, 20 micro. To put 20 micro. Taking linear steps, I put 1 micro each step. Okay. And at here, I can unselect this and I can only run for W. Okay. Do some analysis. Start. It's still selecting everything. Cancel. So make sure you are going for analysis. Start selected. So if you are starting, so it's gonna do for all the variables. So select the start selected. Is it running? Not yet. Start selected. Okay. So now we are varying our capacitor. Now let's check our results. So how capacitor is behaving when it comes to gain. Okay. Seems like no impact on the gain. So everything is on the same line. So let's check our phase then. Let's check both AC gain and phase. Let's see whether it's working or not. Okay, so seems like the output is not much impact on your circuit. So you can just select your 1 picofarad as your capacitor. Seems like there's no impact. There's no heavy impact on your output capacitance value. Okay. So once you change that, so not much changes on it. So you can remain it. Okay, it saves you much more time. Whether you are setting it 1 pico or you are setting it up to 20 pico, it's not going to change anything. Okay. Okay. It's having some bug. Okay. Put it. It's not changing back. Okay, so 20 micro. Can it go 1 micro actually? Yeah, it didn't allow. So okay. And 5. It cannot. So 5 is the minimum I can go. So let's try from 5. Okay, so this is the things that you have to be careful when it comes to arranging components value. So maybe start with 5. Okay, then analysis, start selected. Is it done or error? Yes, it's an error. Genesis, that's selected. Start again, okay. Check again. Yeah, okay. So there's no much changes when you change the output capacitor, okay. So this is on parametric analysis, okay. So you can check for your, okay, for your MOSFET parameters here. So you can even set for your fingers, for your finger width, for your length is limited. So you can only increase the length, okay. So your multiplier, so we just tested with our multiplier and we had our VDC and all that, okay. So this is for your tuning. Let's say you want to tune for example, you want to get your gain, right? You have your gain, okay. So let's say for your one of the NMOS that you set, the size you give was 10 micro, okay, and you are getting a gain of, let's say, 20 dB, okay, and you want to increase and increase and increase, right? So you can just sweep this one 10 to 100 micro and then check how your gain behaves in just one single sweep, okay, and you are getting your maximum. Let's say same line is here, it's different lines, and you have from here is minimum 50 micro to 100 micro. It's like no effect. So what's the value that you're gonna take? Of course, you take 50 micro, okay? Because once you put 50 micro, you already achieve the maximum gain. So that's no longer needed for you to keep on increasing the size, okay? So that's how you do your parametric analysis, okay? It depends on your skills, okay? So that's on parametric analysis, okay? So next, let's try to create a symbol, okay? So how do you create a symbol? Let's create a new library, copy this one. Okay. So I think you can just copy it here. So tools, design, okay, design, save as. So design and save as, you can just name it as opamp _1 or whatever. So this will be saved and we're gonna edit this one. So later, if you want to go back to this one, you just open the file that you name this one. Okay. So opamp _1. Once you save, you can check in your library manager, it is there. So opamp _1. Okay. So let's go back to schematic. Okay. So basically, so our flow here, okay. So the flow of your design in IC design. So you will start with your schematic. Okay. Your schematic design. Okay. Once you've done this in the schematic design, so we'll go to symbol. So this is needed for post layout simulation later, okay, which we are not covering in this syllabus, okay. So once you are done with your symbol, then you will go to your layout. From the symbol here, from the schematic there, so we'll go to our layout. So during layout, we'll be checking for verification, which is our design rule check. Okay, design rule check, which means DRC. Okay, so all the license here is expired. Okay, so for what we have here for design rule check, we can do it with Calibre, the most famous Calibre Mentor graphics, one of the tool. This is the most powerful and mostly used. Okay. The next one we have our Asura, which is basic from Cadence. and we have our PVS. PVS is integrated in the Cadence itself. It's a default software from Cadence. Okay, these are the main three things we're going to use for doing these checks. Okay, verifications, DRC. The next one is also layout versus schematic. LVS. Okay, so this is when you do a layout. Okay, the connection of your layout must be the same as in your schematic. So if it's different, if there is an error or misconnection or no connection, your LVS will detect it and tell you that your layout does not match with your schematic. Okay, you can try later once the license is up. You can try with the caliber later. Okay, so later will we go for 6, which is parasitic extraction is called PEX. Okay? More like RC extraction or RLC, so all that. So all the parasitics in your layout. Okay. So remember when you do your schematic, everything is ideal. Okay, you're connecting, you have your NMOS, you have your transistor, and you're connecting it to another. Okay, so these wires here, the connections here are actually ideal. There are no losses and such. But when you do layout, you're going to use a metal trace to connect. And these metals that you're using to connect like this and all, it's actually consists of losses. You have your resistive losses, you have your parasitic capacitance, you have your parasitic inductance, mutual inductance, all that. And all that gonna impact your design. So always your schematic value is not gonna match your layout value. They're gonna have some certain minor drops in your layout. Okay. So once we are done with packs, the last one we'll be doing is post layout. Post layout simulation. Okay. And in post layout simulation, before verification and all, we'll be having our PVT simulation. PVT, which includes process, voltage, temperature. Okay, that is PVT simulation. Whether to check your design is stable or not. And the most advanced is Monte Carlo. Monte Carlo simulation to check for your design reliability. Okay, and look at the flow. We are basically at here, here, and here. Unfortunately, your time is not good, so the license has expired. If they have that, we might cover, you will have it. So on January or something, you can try it on yourself. Okay, you can go for design rule check, layout versus schematic, and parasitic extraction. Okay, so we have to stop up to these three actually now. We're only covering these three. Okay, so these are the basic things that you need to know on your layouts. Okay, so now let's go into our symbol preparations. Okay, so in symbol, we'll be using pins. Okay, so we won't put all these sources here from the analog library. We'll delete this, delete this. Okay, and with all these labels, okay, there are two ways. Either you straight away connect the pin to that. Okay, so now let's try to insert pin. Add pin. Okay, type your pins. You can type the VDD. So you must know your input, output, and your input output. So input output is basically for your ground. Okay, two ways. So for VDD, we have input. Okay, let's say I want to put VDD. My VN is input and my VP is input. Okay, so I can put like this and height. I can just place it here. So I have my VDD, VN, and VP. So same as the labeling process, you can directly connect it to this or you can label it. So if you want to do labeling, put the wires and label it. VDD, VN, VP. and then put it on the wire, VDD, VN, VP, like that. Okay. And one more, we need to put for our output and we put for our ground. So let's do the shift P, I guess, for pin or just P. No, it's not coming. So add pin, have this one. So I want to put for my output. So I put as V out. Then I have my output. Now I place it here. Then I just connect it to here. Okay. So this is direct connection. Okay. So one more, we add our ground pin, ground. For ground, we select it as input output. Okay. Let's say I can just directly put it here, then connect it there. My ground. Okay. See. So we take out all the sources and we put the pins for it. Okay. So we won't proceed to layout with all the analog library sources. You know why? Once you put that, you take components from other libraries, your DRC will have errors and your LVS won't pass because it will see that the library does not match, because each of them is actually a rule file. It comes from a rule file. Okay. So you can check in your PD case, you will have the rule file actually. So like mine, I have my caliber file here. Let me show you. DRC. So this is the rule file. See, there are generic. So you have all your rules stated here. Okay, I'm just showing an example here. Okay, and we'll have our options here to select. See, DRC options. And in each of the DRC, you can actually select what process are you using. You can define your top metal. Okay, you can define the type of transistor that you use, your metal poly density, your global metal density, antenna check, metal slot check. So all this will be checked based on the rule that you gave. So if you have components from other libraries, so you're going to see it as error and your caliber or LBS or PACS will not run. Okay. So what we'll do, I said, so we take out all the global sources out from the schematic and keep only these pins. Okay. So once you have this, check and save. See if there's any error. Okay. So since no error, so we can proceed to do the symbol. Okay. So go to design, create cell view from cell view. Okay. Once you have this, click OK. And this is how you want to place your pins. Okay. So let's say I want to put my ground at bottom. It's not coming. I have to write. You cannot copy paste. Okay. Ground. So at top, I want to place my VDD. Place my VDD at top. Right is okay. V out. And my left, I want my VN and VP as input. Okay. Once this is done, click OK. And this is my symbol. Okay. I've generated the symbol. Okay. So all this, the editing and all is on advanced level. You can even change this one if you want to edit. Okay. You can just pull down or up or edit the symbol all here. So I leave it to you guys to play around with this. So you can create the triangle shape, the round shape, all that. Okay. So this is just basic to show you how to create a symbol. Okay. Once you do that, you can even edit your names here. Okay, the part name, you can label it as OPAMP, I think. Okay, yeah, here. You can just put that as OPAMP. Okay, name it and all. Okay. So now we have created our symbol with the test bench. So you can turn off this one. Okay, where's the one I saved just now? Okay, this one. So at here, okay, I have my test bench, I have my global sources and all. So what I do, I delete this one. Delete. Now add instance. Okay. Call the symbol that you created. where we created just now, this one. Look, so now this is my symbol here. Okay, so inside here, you can double click and see your schematic. So it's called hierarchy level. So you can go down and come up. So let's say I open this one and double click on it. Oh, I cannot do that on this. So I have to go another way. Is design edit X. Hmm. Okay, it hanged. You guys try to create your own. If you see hanged here, the server hanged. Actually, edit. Fine. Okay, it's not working on here, but on the latest version, you can actually just double click here and then check your schematic. Just coming on this one. Sign, and edit. Okay, there you go. Okay, so you can check what is inside the symbol. Okay, so Shift B to return, and I think is B. Yeah, I need to like design, go to hierarchy, descend, edit. Okay, think I should press Shift X. Yeah, Shift X. Okay, so it's Shift X. Okay, Shift plus X. Okay, to descend into symbol. Okay, to return, it's Shift plus B. This one, return to symbol. Okay, so Shift X for you to go inside the symbol and see what's inside. So then Shift B to return. Okay, so let's try again. So we have our select the symbol, Shift X, and then you'll have this window, descend, okay, and you can see inside the symbol, okay. So you can edit the schematic here, check and save here, and then Shift B to come back to the previous window, okay. So now this is our test bench. So let's can either do it this way or you can directly connect it. Okay, so I want to do it directly. Put my VDD on the top. Okay, here. Here. My V out here. So this one, you can put another pin. Okay, you can just add a pin in order for you to measure your output. So you can just put V out, set it as output. Okay, so here, of course, it's a ground. You are done with your test bench. Okay, so just now we had our full schematic and then we run the simulation. So this one, our schematic is inside here. Okay, so the importance to do this is basically in order for us to do some analysis later, like I said, right? So basically that is for post layout troubleshooting. Okay, so now let's say, for example, I give you an op amp. Okay, you have your amp stage 1. Okay, and it goes to a second stage. You have an amp stage 2. You have your inputs, you have your outputs, and you have your bias circuit here. Okay, P2, you have another bias circuit, P1. So all this. Okay, so let's say, for example, with the full schematic, okay, with the full schematic, you go and do a full layout. Okay, and you want to troubleshoot, the performance is dropped very badly. Okay, so how do you want to troubleshoot? Where do you want to find the fault? So how do you know which part is impacting which part? Okay, when you do it together, everything together, and you need to, whenever it drops or you need to troubleshoot, you need to tweak your full layout, okay, in order to identify where the fault is coming. So when you do symbol by symbol, you have for one symbol, two symbol, 3, 4 here, okay, and you do a part by part schematic, part by part, and you do your layout a part by part also. Okay, in post layout later, you can actually set this one. You can set, okay, let's say you do the schematic layout part by part. You can set this one into schematic, this one into schematic, this one into schematic, and choose this one as post layout. So from here, you can know where the problem is coming. So let's say your performance drop. You check this one is okay in post layout. So and then you change this one to post layout, and you see the performance drop badly. So where's the problem is coming? You can know this is the problem. And what you can do, in the layout, you can straight away go to troubleshooting this one. So this one is already correct. This one is correct. This one is correct. And the only wrong thing is this one. So how do? You straight away do the post layout analysis on this and you troubleshoot only this one. You don't disturb this one. This one is good, good, and good. So that is why we do symbol by symbol. Okay, to catch for the troubleshooting problems. Okay. So once you have this, so same thing, just go to your analog environment, ADE, and we just do the same thing again. 8. Okay, do that. Let's see if there is any variables. Okay, just now we used X, set at multiplier 1, and then we have our W micro, set our DTC 500 milli. Okay, so same thing, you just netlist and run again. I can save. Let's run. Show this. Okay, so once you are done this, so you can direct plot in and phase from your output, your input we add, and you're gonna get the same thing. Okay, it's just your schematic now, it's inside a symbol. Okay. Okay, so try to do this one. We'll have 10 minutes break and then we go for layout. Okay, so we have covered parametric analysis and we have covered symbol. Okay. Yeah. Yeah, and then you create a new one. Save this one. Previous, you can open this one. Delete this one. Delete it. Add instance. I invest on to now all that symbol put it. For your symbol, the symbol level. Put it there. Yeah. So this is now your test bench. Okay.
我分这个也，调整这个版，这个学业的表达的，我们看这个我们是应该是不对的，来自于我们的老板一点。但是，上去，然后有这个东西跳出来，很多经常在做，然后那个。然后，对是这个是所以问题，我们这个三个一个你看，你是不是把你这个上面有没有比较这个东西要复习，我你帮我们听这个小孩儿，他那个所以一开始这个自动他们也学生，把你自己确定，也是。这一次想要不是啊，这个是不要，不要说的这是这个是道，啊，所以这公司有比较这个一个线，这个这个这个。你要去那个现场带来这个那个机构的会议，像那个会议，很多会议，当不能把里面的信息这种东西要写，所以写乱的，所以大家对全部关注到现场，跟你他觉得在把照片需要三个一点就有一个地方，下面的那个它是那个颜色，是这样的。让被主要是的在里面对，然后是喜欢这种，他觉得出现这个就是也是一个，你需要对你起来啊，有机会有可能被在可以就是。然后去你这样这个因为他就是三个好是这样，这是我们是我们的一个。对，是的，是的。比较多这个部分，然后讲一下你这个，啊，现在我一定是在这边沟通的这个差别，这是一个啊，是的，啊，我们因为是我们该是他看就是一个变家啊，一个也会把它写成这个然后这个这里头的变的这个。变成在他们或者是是创始的这个例子，包括这个这个。 一种那个生活也能找到。刚刚那个肯定我们要希望到那里，把这个经历感，Every start,
You have to do all this. Do you of your work? Yeah. You see why it's error, because you have this one and also like that. So you have to delete this, delete all the blue one. Did you save the schematic? Another. Oops, design. Save that. Declarations. Yeah, that. Elements. Is understood. Ignore all that, all this global. Yes, we're creating this cute symbol, right? Now, check and stay. See? It's gone. Now you create.
有把认为是那个把今天那个保存多少
Process.
他这里不带就是追杀我把这个伤一天。啊，这个是
我算就是没有这是，应该说没给起来，
这个我们找一个叫什么？好听。
那我就来
对，是要先把这个这边他，然后在这就可以，但是要的是他，然后这个这个什么？一保证，你说这个一般就是给大家后一句话，
那个后轮，
然后
我以为一个
I 那个电子相信这个啊，那个 block 有。就是好死的，为什么不是？
对了，到点在那，那个多，close everything in it。啊。You just put on your, no need it, so you cannot see it, you can just proceed with simulations. Okay. 就靠在没有，那他们让这样的是配的，
没有，这个吗？这个白的什么？ 还是那个对，现在把那一旦哎，就找我们把那个情报，我哪知道我是哪？命名是看是这个，那个还是那个，这个对吧？教我的那个，你看。
It's just some fun, you know. Makes a lot of things. Sometimes when you post the community can open back, but they will perform. Sometimes you need to off all the cadence and everything. So that's usually right. No. But I continue.
就创造的是你来吧，就是那个啊，小孩或者是那个
checking for the go inside.
放在点赞，对，那是 save view，放 save view，放 save view，然后会有什么
Yes. The history.
按照那个分选，还有就是比那个好的会留下保留有影响，是PPT上面，让他们数据上面对的，这样顺利，对内容，因为他们写的让你说的好的人，好听话，这在上面顺序体育练习。这个方式你要结合多的方式，然后拼这个是音符的因为你给拼这个，这个很敏感，然后那个意思音符的要用那个意思的音符。这个是CVS 不点的退，退。等下，找到那个 C 看这个 C 应该有个半个出来，这个当时我是吧？这个应该不管以后的那个这个我对，然后把这个插进去，前面这个直接删掉。因为这个是然后再往那新本上，然后再个新的
Yeah. So, Susan is recently open schematic. Did you save this one?
It's就讲的，
This one is one of the open string and the thing goes on. We call this, we call the word is schematic. Schematic.
Oh, the one that
Yeah, so you have a symbol, right? So you have only symbol. It cannot all the other people. Which one is actually automatic? This one top, right? The schematic. But schematic only rests in the yeah, cannot left or save it here. The view must be used. You save it. So now you have your file, right? So this is your file. Go back. Okay. So you already created a symbol. Now shift X to this one. Okay. Will ask you to present that to the schematic. Now so this one. This one from here. On this library. So this one is actually this one is symbol by geometry. So this one is from this plus It's open, right? You can check the Portuguese, where it comes from. The library name, the name of that. That name is open. It's calling this open to stream. Same library, you should put it in the same cell, not separate. Okay, so if you put in separate cell, you get this, like you only have symbol, but right is when I create a symbol, I want to change. So I think that's so you just check and save for me. I never save, no need to save as only. So I asked to save as to have different design. Like now you have this one, right? This one is more than program. So now you have open 3. So open underscore 3 to the test bench. Okay. It's a test bench, but we call the original symbol from it. Okay. So you can even create a new library. Let's say you want to save as on just put it as stand name if we test bench. You are inserting your symbol here. This is the original format of this is the original one, right? So and then so let's say I just copy it. Let's say open that is in those cases, it's the same thing, right? Okay. So this is your test bench. So in order to create this test bench, you just do a new cell, or you can just save as because we already do the library, right? So I want to save your time. So I want to do
这个 symbol 你可以当成这个
now this is your test bench. Yeah, but it's like the test bench. Which schematic are you calling?
Yeah.
Inside the symbol is the schematic form. There's your test bench. The same thing, like just then we did a full schematic and we connect one. So now inside here is your schematic. So this is below the so you want to shift. Yeah, so you want to go back and shift. So connect all this and then run the simulation. You can get and you see whether you get to play. I just end up with college. We have to come in the same one. So it makes the play.
你先，
所以我你本来原来的是放置，
你怎么？从你怎么不写？这怎么办呢？你要是把没把这个地方，我把这个
其实并非太基本的东西，
这个
然后这个出来做一个是，然后我们是开一个
你不要多说。
这个没听到一个，
你放到眼睛直接把这个柜上去，要是有
正好透出来的，你不能打开这个实验对，它只能只要添加分布。
Once you guys are done, then we proceed.
不把它做成新的
就是那个你刚刚说的。
Okay, thank you. That's what you can see.
I mean, they make really works. 这个保持原因。对，还有前面的力量。
对啊，
这个让你怎么接？
你把这个新的话，你要有自己的
You watch the video, you check the video. So that's it.
应该没这样，跟老师好像就接着这情况的，或者是连接。 对，这里边是公司的问题，英国肯定也在不了的。
对，我不是感觉不一样。
这事儿，
那为什么那个就他后来不是又把这个数在一个那个
对，
有点就是这个
就第一次的那个，
哦，那有条件把那个 symbol 复制过去，然后一个那个不是这个不是啊，怎么去重新打
用那个第一个，对，
那单直接那个可以买到
这三个有啥的？我也不知道是啥。
那个好多那个那个东西都没有，这个
出一个 CD，
所以回去前来这里，然后那前阵这样的，
没事，其实直接输就好了，它只要有一个对子。
这个暂停给老师，他卡过，
现在不地方
那个然后他去整要教那个形容词，就去发
导致组织让它转，
我
是那今天里边80吧，就是80转吧，就是没有 shift 啊，shift 加10，点那个期间 shift，期间那个期啊，你那个期间也不是因为下不是，你这个期间你这个是，就是shift 是啥？这玩意儿就是。你看那个三个，啊，你看那个，
三个是也专门
啊，这个不是这个你看，放出来平常的是一个然后平常看看有没有个性，所以你可以放一个来个
还是要
很多的。
加进去，
没有，是我越
啊，按你说的，应该有本质这么一点，并且的跟上面的运动的，塞的，有一些他们是用这个的，我包括是
一般它便于那个地下嘛，
我看到的
这种
就是
所以他就根本就是这种，他就是按那个给烧死的，然后他就不转了，
很多光这个
你还是用电，
然后我说就把这个删掉，对吧？然后这里我的三个，两个。好，对对对，我两个很多。说你的情况是这样的，还是没有？就他有这三个，我另外一个，这个就比较，
是一样的，就是好大。
然后就是这个上面你用20分钟那个选中，然后我你看你这所有的推行词汇，非常二本身那个这样，放然后我这边是
也就放在它中间也可以。
你看俩是那个
不是这样，
被去的那种，
对。
因为比方它
一个按那个两个也是可以给，
有一个
我就按你直接用，然后对啊，
然后
对，可以转嘛，但是就是跟我这个是必须不要移动的，对，你现在你按那个
这就有点不行，
是不是？ 你现在是不是特的？
还主要这个对，主要是先
不用这个就没用，没用。你播的时候一点邮件它不让你。
Can be done. 10 mega is enough.
文件啥？哎，我咋不行？你那些都是。按上面的 VDD VDD， VDD 对啊，按上面 VDD， 这个就是对。
超跑机嘛，在我有机会我给他有那个你可以能是。是吗？就是三楼，我觉得是是有那个是有一定的，特别是会三个这个新差，而且就是我来这个你现在这个泡泡片，你跟平时这么多版都是你还有差不多那两个，也就是到底是病啊这个东西，他们有一个工作反应的是先方是在位的，你看。那是有病的。一个是放在方的，你看那个是没放的比较死。我拉过去看不清楚。对啊，我觉得这不会在吗？你都不要在那个如果你要放别的话，就要打这个没有先要教学群到。明白，那个理解是。防治病它有点像力量皮后面就是哎，然后是大点是吧？因为要的比方有时的地方是到有啥不行？你按两地没就可以。按两地，按两地再给个后，然后你再去搞。没用，哎，好了好了，有了，是不按的。好，你按一下 R 还有左键一个，这个主要左键一个，对。
Yeah, the sound. 无所谓，这个地方 signal 的频，一样的频。Yes, signal and view. Signal amplifier. Let's say 10 microvolt.
没事没事，哎，这样就行了。然后我就找给他们这个。这里面录那是
sure. Sometimes it's even sometimes it's faster. Oh. 先把线连，然后把好，先把一个然后再上。不是信号两个手，不能自己的气。连上来一个。你从来放。刚才一个 out 不要出头啊，那个你的 GND 还要加一个 GND， 少还有 GND 在。我现在 GND 是哦，这还不一样，是完全是正常的。你这放的线用绳子，你这样，这个是用绳，然后这个这里是别的，算你要下，
这儿有个微药的，对，要在这个对
假设你会问，这个是没有想过，这个现在是还是问，
对你这个
一个现在
名字就这样的。
然后这样子这样
就是相当于那个时候，那个是那是外面接触这个，打了个特别的是我刚才进入也是yeah，那个水分在那个他一冲，我们考虑到这个原因，这边占了。
So once you see these like so all or by this video, yeah, I think yeah, all I use and I should finish just something. They're using the games for this one. Yeah. So you're measuring gain.
对，你看你们
Such
没关系的，我本身没关系。
easy gain base.
没关联，可是我创建的时候就是应该是创建。我感觉你应该只是单纯创造一个 C 图，就是前面还有一些步骤，一些词给你清楚。然后我记得基本上好像还对的。那我怎么打开那个啊？怎么样？我把这个删掉，没有警告吗？我都想重新创建，这次一推把这删掉，可能你保存另上的，就不需要另上，就本来就是个手。我记得好像是那个什么，你在一个 H 那个开头，这里把它删掉，这个就删掉，几个这个，那个 descending 是吧？或者那小 slow， 就没有 slow 了，哦，你看这个。就是从这个上面是这个附近。一个 D 站，然后一个 H 下 H， 那是第那是打开。这个 HIER， 对，这个是打开那个底色的，打开那个是打开那个有，嗯，是。好。这个里面我另用全删呀，待会儿把这个给代替一下。第一个是这个不是找啊，还是对，你打开那个，打那个骗人，也是那个水果打的那个那个方面，有两点变的是，我给你说，他们这个办的那个就是不是打开的话，那可以全要的那个也是放在的，放在这个备忘录里面，是这个我那个别人 copy。因为我有朋友来给你划船，他那个对正常是那样，但是稍微还有回去的版本，他这个然后我那那个历史历史里面，
Doesn't matter what you type in, type search for. So once you export this,
那个就是还原年龄的那个下面的会有并联会，
它被是这个，
然后
yes, because for we want to go to the layout. So for when you're doing layout, we have to do that. So you cannot put the
最后感觉
you cannot do all in this. So then you find what you say.
第一个找不着了。
Yeah, it's okay. Because schematic is like a
因为
straight.
它那边上对，就是这个。
Okay.
当时是一个变成这样。
So now shift B. They done.
都没有钱了。本来这个然后就把这个把这个原来是
你对我来说就
要保证这个这种联网，比如说你其他没不得放久，
那都是那个调用的。
好是原生是一个现在就这个写包的这个现在是要做包括间一写这个20是水一到
对，谢谢。一个半，要一半。还是把我现在就是，哎呀，没水，然后推转，对，当，然后会让，看看那个听这个，还有那个时间，他上不了，这个挺好。
It does not take the time. Just
也上面容易翻用不上，对不对？
so in the group I put the recording on plus
对，上一次我是想给你做那个，
把那个这个 link the time one
热情，有那些上完全把更加完那个前方的产品，又会那个
recently recording. We will find record this. You have your website. Email.
上面我直接对，就是我一些情绪这个对，这可以，它可以转到我这边，一个就在那重新。这应该也是个是
That's not.
那个200应该
So you can
我觉得
like the
这个都是稍微可以运动到没事，他肯定愿意换。
这个嘛，这个现在有是就这到
yeah.
This one 再加
就是一个然后把这个放。
This one is for so we don't create new symbol.
这才能
Must have schematic here. So you must do here, which where you do this one. So this is your schematic. This is your symbol, right? We don't do new cell symbol. No. When you do a cell view, inside that cell view, you must have your schematic and symbol. So understand. So now, This one we know. On this one, take for yes, sir. This one. Thanks to one. This one. So now this one has schematic inside. This one you can show, right? Same. Oh, what's fun? Okay, this one is also where's your schematic? Schematic. How you get this one? Yeah, can you modify this?
This is the same.
Same the same. Then where's your schematic?
Same as.
Where's your schematic? You must have your full back.
I covered the first class. From
Yes, where's the full schematic? Did you did it?
No, I covered.
Where?
It's this, but I covered it.
No, cannot do that. So it's like now you're. So you must, that one must have the inside. Understand? Okay.
So the single yeah.
Yeah, from center. Okay. Okay, and then you arrange the pin. But you must put pin first. Where's your pin? Because never add the pin first. VDD, round, VM, VP, all that. Okay.
What is in就是那根本，这是第三啊。那我可以用这只发一个，这个给发，就一个，这不是那个虚拟结构方面这个方法，它可能会也是它的刀可以把它变得发，应该是没色，颜色它的流的，最大是这个黄颜色，问题它不行，因为你个会的，会我只有皮看过这个，是万能包的分享的是，就是很平的那个不晓得，这个三个可以抓这个，10万的包的圈3秒，哦，马上要是自己把这个好的，因为我是对应起的这个拼也，拼也，就这3个。
Okay, just some explanation. Okay, so you have your schematic. Okay, let's say you have your schematic. Okay, this is your schematic. Okay, so this is the schematic that we do symbol. Okay, and inside your symbol should have the schematic. Okay, so it will be like this. You have your VDDs, we have your ground, you have your output, all that. Okay, so means the schematic here, you don't create new cell view. You have your library. Okay, you have your cell view. Okay, then what's the other one? It's the view, I think. Okay, you have your cell view and then you have your view. Okay, Let's say your library name is X, your cell view name is X1, and here you should have your schematic, and then you'll have your spectral state you saved, and you will have your symbol here. Okay, don't do symbol new one. Okay, so this means that your symbol here is the one we'll call your schematic. Understand? So inside this symbol, inside this is your schematic. This one. Okay. So don't do new symbol, don't do new schematic. Okay, so it should be inside. Okay, all in single view. Later, when you do layout, so one more you will have here is your layout. Okay, so it should be all on the same view. And when you create a new library, okay, let's say you have cell view x1 underscore tb, your test batch, and in this tb you will call this symbol. Okay, the view will be schematic. You have your schematic. Okay, in this schematic you will put your symbol, and this symbol from where? From here. Okay, so this symbol from here will be inside your test bench. Okay, so make sure your symbol and your schematic is together. Yes, then only you can call the schematic from the symbol. Okay, should be like this. See, so I have my op-amp schematic, my spectral state, my symbol, my layout, all like that. So and then I call my test bench. Okay, so this test bench is actually on op-amp underscore 1. You see here, this op-amp underscore 1 is my test bench, and this schematic, you can press here Q and check where it is from. You can see it's from libraries, Selva op-amp, cell name op-amp, and view name op-amp, which is from here. Selva op-amp, and here the symbol. Okay, so that is how you check. Okay. Here, here you send under the one SAVDC. That's because then you just send from 0 on the step size will be 0 to the
你别关，有的一关还得放。
Yeah, you can also handle no, X is a multiplier. You just put numbers 1 and how many fonts you're loading? 60. Yeah, so you want 60. So is it running a source and running okay. So memory is like sometimes you click it one time, so click it. So make sure this one is yeah. So now it's not one thing.
But it's not really also about it. Just that when I want to plot the graph,
VN or V out and VN 因为它是这个那个，你其他的不要给保存。风险保存对谁上面打个招呼，我现在大家我稍微你不要电保存就不会坏的，你电脑保存就会坏。这样，那我们如果连个保存是四百一个，然后4个 S。那个 my first sense
你改第二嘛？
改掉这个，好的，对。
That's the phone one. So but this one should be DC if you want to check.
把第一个当然搜保存的
And good. Yes. Then we must leave it like
不要做，
it should be slow.
这么多文件全给覆盖了。
That one should be
你要就第一个，
put a empty small at the bottom. Put one word if you make it. Okay. Yes. There you have it. So the supply should be here. Okay. Okay. There you go. Six.
She said, let's just go back and tell us that the next thing. Yeah, but yeah, but I know we all first to the room guy that is hey, can I see something? It was the illustrated. Should we be doing? Maybe get that something from so you do. No. It's not much it's not. It's what. If that's the situation, very good, you can share with me. I
Yeah, right. So it's gonna be slow because then it takes 69. Okay. So if you see it's like getting too slow, so just do it one by one. Want to sweep VDC first, X first, do it one by one. Okay. So if not, you're gonna overload your software later. Okay, so it's already 5. So let's continue to layout. Okay, so one of the bug that I want to insist here is this one, your layer window here. Okay, so once you open your layout, so this thing you cannot close, so it will just be there. Okay, so in order to do that, you have to close everything and start again. Okay, so what I'm gonna do is gonna close everything. For you no need, because you never opened the layout yet. I already opened. Okay, I just cannot get this disappeared. Okay, so I need to close everything here. Okay, let me open back. FB. I configure my PDK. Wait. Okay, here, open. Okay, so this is my schematic now. Okay, I want to open my layout. So you go to here, tools, design synthesis, layout Excel. Okay, so click that, you'll have this startup option. So yours will be create new. Okay, mine is already there. So I open existing. Then it will come here, just okay. Okay, so now you see my window is here. So layer selection window is popping up and my layout is loading. So settings for the layout is very important. Okay, so you must at least know how to do the full settings for it. Okay, so let's have a look on it. Okay, so this one I just close it, and this is how you will find your layout. Okay, so it will show in a box. Okay, a black box. To change this, you must press E, the display options. Okay, press E to change the display option. Okay, so first thing, enable the pin names. Check the pin names. Make the grid none, and the grid should be on 005 coordinate. 5 filter is 0.1. A snap mode is diagonal, diagonal, and this one is top 32. So this is how your final setting should look like. Okay, your display options. Okay, so once you click OK, it will show all the layers. Okay, so you can see all the layers, and these are your MOSFETs, PMOS, your NMOS, your capacitors. So this is what we basically have. Okay, so before I explain, so this is 2D view. You are looking from the top. Okay, the chip, the layout, you are looking from the top. You can only see it in 2D. So when you look at this, you're actually having from the top metal, metal 6, 5, 4, 3, 2, 1, and you are seeing it from the top. Okay, so let me show you some example. samples. Okay, so these are your hotkeys, your layout hotkeys. Okay, so F to fit. So all this you can go through later. So for this, I will just do together with you. Okay, so these are the layers selection window. Okay, so all the metal layers you can see from here. Okay, so AV means all layers are visible. Okay, you can see one by one. So NV means all layers are invisible. You can see only the layers that you want to see. Okay, so AS is all visible layers selectable, and NS all visible layers is unselectable. So these are the options that you have. We have instances, pin selectable, an active layer, on which layer you are using, all that, and these are the layer list. Okay, so 2D view in Cadence. So you actually, this is an example. Okay, example of a layout with the inductor and capacitor, and your MOSFETs are over here, MOSFETs, resistors, and you are looking from the top. Okay, so if you want to have a high imagination, it's actually, imagine you are wiring a building. Okay, a building like a floor by floor, from the 6th floor up to the 1st floor. Okay, that is how you do the connection actually. Okay, so to get the visualization, so this is how your stack up looks like. Okay, this is from metal 6, then metal 5, 4, 3, 2, 1 until the bottom. Okay, so let's say you have one metal 6 and the bottom one metal 1. How do you want to connect that? So we'll put via. Okay, so we can put from via 5 up to via 1 in order to connect from metal 5 to metal 1. Okay, so if you're pulling only everything metal 1, you might short them. Okay, so beware, you are not connecting any nets together on the same metal layers. So how do you do that? So let's look this video here. You can see. So this is a 3D representation using Sonnet EM. Okay. So you're seeing from the top here, your transistors, your resistors, inductor and all. And when you flip it, so this is how the stack up looks like. You can see or not. So this is how your layout is. Okay. So it is not on the same layers. One is on the top, one is on the bottom. And when you put a via, so look how it's connected. Okay. So let's say you have a metal 1 in between and you want to bypass that metal. So how do you do that? You just go through a metal 2, the top, and you do a bridge. Okay. So this is for you to just to get a visualization on how you're going to do a layout later. Okay. Okay. Okay, so at here, for example, let's look at here. So this is my metal 1 and metal 1. Okay, so this is my gate and source, but I cannot pull them because I have this bulk here. Okay, so I cannot pull directly metal 1 and metal 1 here because it will short. I will short them. Okay, so instead of shorting them, what I do, I take from metal 1, I go to top up to metal 3 here. 3, and from the metal 3, I go back down here. I avoid shorting this net. Okay, go up, and then I do a bridge and then connect them back. Okay, so this is just a visualization for you guys. Okay, so now let's go back to here. Okay, so remember your MOSFET is a 3-terminal device, 4-terminal device. So we have our bulb, but in your layout, there is no bulk here. You have your gate. This is your gate, your drain, and your source. Okay, so typical layout MOSFET architecture. Okay, so if you look at closely here, this is your poly, your gate. Okay, poly in the middle, your drain and source. Poly in the middle, your drain and source. So how do you know this is poly? You can look at a layer selection. So select poly, and you can put NV. Click on the layout and press F to refresh it. See? So this is only the poly layers. You can only see the poly layers. So when you select all back and press refresh this again, you can see all the layers. So let's say I want to view my metal 1 only now. I select metal 1. I select metal 1 only. And I refresh. It will show metal 1 only. Okay. I want to check metal 1 and poly together. Metal 1 and poly. Then I refresh. See? So all the layers. So this is how you check the layers. Okay. So now is all the metals, all the pins are there. So we don't have the bulk. So what do you do? Go back to your schematic. Okay. Okay, I missed one point for you guys. So how to call the components? Okay. So how do you call your components? Sorry. So this one I just delete first. Okay. So I have no component. When you open, it's empty like this. So you go to your design. Okay. Okay, let me check. Is it design or create? Okay, it hang. Okay, you must go to your tools. Okay, it hang. Give me a moment. Okay, go to your tools. Click on tools, design. Ah, this is hang. Sorry guys, my thing is and design. This, not this. Wait on, let me find where it is. Tools. Okay, this one, generate from source. Okay, go to your design, generate from source. Once you click that, you will get this. Okay, so for now we don't need IO pins, we don't need boundary. Okay, so just instances only. Okay, so once you click OK, so all the instances will come as in your schematic. Okay, so normally your schematic design will have the options. Okay, for example, let's take this PHP. Once you click that, okay, you can select your gate components and the body type. So your body type is the bulk. Okay, so let me show you an example of. Okay, so I have my left tab, right tab, bottom tab. So it's going to create a ring. Click OK. So go back. Now I want to do it again. Generate from source. Yes. Okay, it's loading. Okay. For example, it's like you have your MOSFET. Okay, so at first you see this one, right? You add your poly, which is your gate. Okay, so and then you had your source and drain, which is your metal one. Okay, your source, your drain. So what about your bulk? So MOSFETs usually have bulk. Okay, the bulk here you must set. So that's the option you are having, either left, top, bottom, left, right. So when you select all, you will have a bulk connection like this. Okay, so for PMOS, this should be VDD. Connect to VDD when it's PMOS. It should be to ground when it's NMOS. Your body, remember this one. Okay, your PMOS. So where your bulk is connected, so it should be your source. For NMOS, same. You have this where your body is connected to your source. And NMOS source is always ground, and PMOS source is always VDD. Okay, so let's have a look on the layout. Okay, select this. Make sure you you can update the thing. Okay. See, so this one, I cannot use a mouse, so this one is quite tough. Shift Z, okay, so Shift Z is zoom out and Control Z is zoom in. Okay, so Shift Z. Shift plus Z equals to zoom in, zoom out actually. Zoom out, and then Control plus Z to zoom in. Okay, so let's test it out. So I'm using Control Z, it zooms in, Shift Z, zoom out. Okay, so now have a look on this. So I put my bulk, can see or not. Okay, so if I take that option away, I can even select here and go to my parameters. Okay, can check in my parameters here, can see or not. I have my gate connection, top, bottom, both or alternate. So this is your gate, right? So if you change to bottom, look how it changed. Your gate comes to below. Okay, so that depends on you. If you select both, look your connection, top here and bottom here. Okay, so when you're doing layout, maybe you want to access the gate in both sides, so you can select both, connect here and also connect there. Okay, so that's one of the options. Okay, so next one, look at the body type. So body type is your bulk. Okay, now I put detached, right? So let's say I take left tab out. See, the left tab is gone. Okay, if you didn't select anything, right, so it will be empty like this. Okay, so make sure it's a ring. across your MOSFET. So make sure it's a ring. So select all this, okay? Left tab, right tab, bottom and top, and apply. You'll get this bulb. Okay. So you must do it for, in the schematic, do it for all the transistors. Okay. Like this one. Make sure body type is detached. Like all. Okay. Same for this. Attached. Like all. So for NMOS, attached. All. Attached. Okay. So this attach. Like for all. Also this one. All. And for capacitor, so the bulk is always connected to ground. So instead of N tap, so there are two tap type option here. N tap, we connect to VDD. Okay. So we have two type of taps. So you have your capacitor in between, right? Your cap, your inductor. So all of them will have a body, will have the bulk. This you can see in your schematic where it is shown by your symbol here. Can see or not? This body here. This one. You have your positive, you have your negative, but what about this ring here? Okay, so that is the ring that is shown by the property there. Okay, so normally we have two options: N tap, connect to VDD, P tap, connect to ground. Okay, select this one, press Q, and here tap type option, change it to P tap. Okay, then select OK. So once you're done, check and save, and let's update our layout. Okay, the design, generate from source, yes, layout generation. Okay, see, so now we have the bulk for all the MOSFETs. Okay, bulk here, we have bulk here, and also we have capacitor. This is our capacitor. So we have our connection. You can see here, you have your minus, plus. Okay, so this is minus, this is your plus, and B is your body, your bulk. Okay, so you can always refer to that. Okay, so also here, it's not labeled here actually. So it's supposed to have drain and source. Okay. Okay. So this one, you can move. So just an amateur level first. M, same thing. You just click and then you just move. As you move, you can see where the pins are connected. Okay. You can align them by pressing A. Okay. For example, I want to move this one. I select this. I press A. Click on this. Oh no, the key is different on this one. It's not A. So in order to align, is there any align? Okay, no, there's no align here. So that's on the latest version. Okay, so this one can just place it here. It's quite slow. Okay, so I just roughly show you guys. Okay, and then this is your NMOS, the bottom one. You can move, put it here. This is my bottom and MOS. Here. Escape. I move my cap over here. Okay. So the schematic. So from based on your schematic, so this is your layout. Okay. So you have all your components. Okay. Now, how do you see the layers? Go to here and then you check your metal one and then refresh. So this is your metal one. Okay. So your connection basically, so on how you identify. Okay. So you see here, you have your bulk is metal one. Okay. So that's right. So you have bulk metal one. Okay. Your gate also metal one. You have your source also metal one, and you have your drain, which also metal one. So this is for MOSFET. Okay. What else you have? You have your resistor. And no resistor here. You have only have capacitor. So check your capacitor. Okay. So this one you can get from the document, but from here, so your capacitor bulk is metal one. Okay. So this is your capacitor. So basically your capacitor bulk is metal one. So what about the plus and minus? Which metal are they located? Okay. Let's have a look. All. So your plus and minus are here. Okay, so based on the document, I'll just tell you your positive should be your metal 6. See, so this will be your plus. Okay, and your minus will be your metal. Let's check. 6 and metal 5. 5. See, so we have metal 5 and metal 6. So if you want to enable the text, let's try, let's find the text. Where's the text? Only one text. Device text, I think. No, it's not. Let's enable everything. Okay. So you have your plus on metal 6 and you have your minus on metal 5. The bottom one is metal 5. Okay. So it's true. So your plus is on metal 6. 6. And your minus is on metal 5. Okay. And we need to do a connection, something like this. So based on the stack that you saw, this is the stack. Okay. The number of stack. Okay. So you need to connect from metal 1. You need to use your metal 1, metal 6, and metal 5. And basically, you cannot short any of them. Okay. For example. Okay. So how do you check which one is which? So you click on this and then check your schematic. It will show your schematic. See. So this is the box there, the white box. Okay. So that will show which layout is yours. Okay. You want to find this one. Okay. Which transistor? I select this one. This one is where I click on that and it will show this is my MOSFET. Okay, you click in the layout and compare in your schematic to know which layout is which. Okay, so now let's say I want to connect the top one, all the VDDs. Okay, so I go back here. The bulbs are all VDD. Okay, so this is my PMOS. Okay, so these are my PMOS. Want to connect? Think it's P. Okay, press P for wire. Okay, to add wire, and then you can select metal 1. Okay, so see how it's coming. Okay, I just show a rough drawing only. Okay, so I want to connect my bulk and bulk with metal 1. So it's connected now. You can see or not. So in my schematic, all my bulks, PMOS of bulk going to VDD, going to VDD, and this bulk also going to VDD. Okay, so I connect all the VDDs together in my layout. Then I press P again, this metal, select metal 1. Okay, and I just pull this one. Now it's connected or not, or the metal 1. Okay, and I can also use R to draw a rectangle on metal 1. See? So it's all connected. Okay, so please note when I draw it on that metal, you can see or not. So it's showing the full connections. The green color, it will highlight for you which net you are connecting to. Okay, so it's kind of assisting you. The latest version is much more user friendly actually. So you can just place on the metal and just pull like that. So since this is the old version, it's like a lot of manual stuff. Okay. So now I have connected. Now look, all my metal 1 for the bulk is connected, correct or not? So now, what is next? I want to connect these gates and these gates together. Okay, so these two gates I want to connect together. So which are my gates? This is my gate, gate and gate, correct? Now I want to pull from here, metal 1. Okay, I want to pull it here. Can see or not? It highlights for you. Okay, see, it's on green color. But can I do that? Can I do that with metal 1? Can I do that with metal 1? See, it blinks. Why? Because it's shorted at here. Okay, so because metal 1 and metal 1 hits, so it shouldn't hit because my gate is separate and the bulk is separate. So my gate is not connected to the bulk. So I must make sure it is not shorted. I cannot use same type of metal. Okay, so what I can do, I can select this Q and I change it to metal 2 drawing. I go one layer on the top. So DG is drawing. And I change this one. It becomes metal 2. See or not? Okay. I just move this one at the center like that. Okay. But is it connected yet? Of course not. You need to poke down. Now, for example, for this, right? If you see in 3D, you have metal 1 on the bottom. You have metal 1 connected here. Okay. And on the bottom, on the top, you have your metal 2. Is it connected? No, because it's top and bottom. So in order to connect, you must put a VR. You must put a VR. Now it is connected. So how we put VR? We put VR, we press O for VR. Okay. So when you press O for VR, press O, you will see this window, create contact. So from where to where? So my contact type should be, so this is very manual. Okay, you have to put the VR. Let's say you have from metal 6 to metal 1, you have to put metal 6 to 5, 5 to 4, 4 to 3, like that. But in latest version, you don't need to do that. You have just two metal on the top and you just click on it, it will put for you. More automated. Okay, in the latest version. So now I have to put from metal 2 to metal 1. So I select this one, metal 2 to metal 1, and I just punch it there. I put it here. Okay, here. But since we cannot check our DRC, so we just learn to draw first. Okay, so you must make sure our layers are no DRC errors when you run the DRC. So now it's connected or not. My gate and gate is connected from this gate to this gate. Am I right? From this gate to this gate. And here for this, it's connected from gate to my drain. Okay, gate to drain. Let's have a look. So this MOSFET here, the gate must be connected to one of the drains. So which one is drain now? Let's find out. So I pull this one. So where it's going? So this is the drain, correct or not? So it's showing you should connect from here to the gate, correct? So if you select the side one and you click on that, metal one, okay, this one should be your source because source is connected to VDD, correct or not? Okay, if you see your schematic, see, so this is how it will highlight for you. Okay, your VDD is actually connected, all the source are connected to VDD and all the bulk, the body of the PMOS are connected to VDD. Okay, so that is how you determine it. So this one must go to there, while this one is connected to your gate. Okay, it's highlighted. If you check your schematic, where does it show? See, so that is the net that you need to connect. Okay, so since no obstacles, so we can just connect it like that. See, diameter one. So I just do roughly first, and I just connect it like this. So it's connected or not? So it's connected. My drain and my gate are connected now. Metal one to metal one. So now all the sources I must connect to VDD. I just pull this one. Okay. I can either do that or I can just press R and draw a rectangle like that. See, and just draw like that. So it's connected. Connected. And also this one, I just put a big metal one from here up to down here. See, so now all my VDD and bulk is connected. All the source and this one are connected. So now the next one I have to connect is, okay, so all these are settled, this is settled for this transistor. So I have gate to drain as well. Okay, then I want to check it here. So this gate and drain are connected. The same like before. So I want to connect the gate and this one. Okay, connected. So I'm done with that part as well. So this is done. All the top one is done. So now from this, okay, so I take this one first. From this drain and drain of the PMOS, it goes to the drain of the NMOS. So let's see where it goes. So I want to move this one closer. Okay, move this one closer. Okay, and I can check. Just press P, and I try to find out where this one is going. Okay, close. Okay, so that one is source. So this one should be the drain. Correct? See, it goes there. So how do you want to, instead of pulling it like this and like that, instead of you going like this, like that, right? So you can just flip it. Okay, so you can select here, then you can edit, and then shape, delete. Okay, wait, need to see the tools. Okay, let's try whether it works or not. Move. It doesn't work. How do I flip in IC5? So edit, move, copy, wire, stretch. Fit, save, copy, move, stretch, fit, ruler, shift, show. Okay, I need to check for the okay, let me find the shortcut. Yes, you can try draw as well. Okay, so I found it. So you have to use right click. Okay, click the component, press M, move. While moving, you right click, it rotates. You see, so it's rotating. Okay, it rotates. And to flip, shift and right click. So when you shift and right click, it shift for you. See it all. So it's going up and down, mirroring. Okay, so I put like this, and I want to flip it. I move first, and then I right click. I shift F, shift right click, press shift and right click, and it will flip for you. Okay, you write it down. Okay, so rotate equals to press M plus right click. Okay, okay, to flip or mirror, then M plus shift plus right click. Okay, so just now I want to connect my drain to the source of this, right? So I want to move this date, date, date. Right. Is it here? So is it flipped yet? Let's check. Not yet. So I want to flip now. So M date shift Okay, now I guess it's flipped. Let's guess. Okay, see? So now this one and this one is straight forward. Okay, so I can just move it a bit. Okay, bit. I want to connect this drain to this drain. Okay, so let's press P. I take this metal one. I just try to connect it like this. Okay, or much more easier, I will just put a rectangle. Select R. Okay, select R. I just draw the rectangle, but I select metal 2. Select metal 2. I put up to here like that. Okay, I have my metal 2, and this one I just move it a bit. So now I have my drain and source of the PMOS connected. Okay, but first put a VR. Okay, so now you have metal 2 to metal 1. You have one VR here. So how do you make it a lot? So you can put it here, your rows or columns. You can put 4, you become 4 like this. See, so you'll have 4 layers. So let's say I need 6 and column 1. So I can just put it, take and put it here. Okay, like that. So then I just take it and put it here. One, right. Okay, I want to put a VR here. I want to penetrate my metal 2 to metal 1, and that's it, connected. Okay, so now my source and drain to drain is connected, which is this part. Connected. Now this part, my drain and source of this transistor. Okay, let's check. Same thing. Okay, so yeah, so it is located same. And to copy, let's say I just want to copy it. Okay, I can just select like this, press C to copy. Then you can just move it like that. See? Because it's same thing, right? You can just press C and move it. Okay. And this one you can just slightly adjust it a bit. Okay. So now all connected, correct or not? So my drain drain of PMOS to drain of NMOS, drain of PMOS to drain of NMOS is connected. So more like this part is solved up to here. So up to capacitor later. So we deal with that later. Okay. So next, these are all NMOS. So for NMOS, all the metal one is separated. So it should go to ground. Okay. So going here, this is my NMOS and NMOS. Okay. So and I put this NMOS closer, this NMOS closer. And I want to connect all these grounds together. Okay. So another thing you can do, press R rectangle, just sharing my skills. You can just create a big metal one like this. Okay. But you need to cut everything. So to cut is Shift C, and you can chop. So let's say I want to chop from here to here. I select the metal and then I just chop it. See, I select this metal, I just Shift C and chop it. Shift C and chop and chop. It's more like using SolidWorks, the AutoCADs. You guys have used it before. Okay, like that. Okay, see. So settle. All the bulbs is connected. Okay, and next is all the sources, all the bulbs. Just now I connect all the bulbs. All the bulbs is connected to ground together, metal one. Now I need to connect all these source, these two sources to ground. These two sources are going into this MOSFET. So these two are connected to ground. So what I do, Okay, so these two sources, right? So these two. Okay, so I need to check which one is the source now. Is one source? Yeah, you can just connect it like that. So it's connected source to your ground. So for this one, see, no, it's separate. So it's going to the top, I think. Yeah, it's this one. It's a different net. Okay, it's this net, not the ground. So it should be the other one is the ground. This one is the ground. Let's select it. Ground. It's connected. Okay. So and now I want to connect from here all this. So we know this one, right? So this layers just now. So this connect to here and this connect to here. So I can just use metal 2 like just now. So I just put a, let's go to the layer selection window. I use metal 2. I just draw a rectangle. Up to here. And I draw up to here. Here. See? So and then I put my VR. Metal 2 to metal 1. I have a row of 4. Make it long. Here. Here. And here. See? So it is all connected now. Okay. So which layer, which net? This net. Okay. So that net is already connected at here. All done. So from metal 2 to metal 1. Okay. So now what about the gates? So I have one gate here, gate here, gate here, gate here. So where do I connect that? Check in the schematic. So this gate and this gate is our input and output. So what we do, we just pull them out, okay, in order for us to supply your pins, okay. So how do you do that? We have metal 2 and metal 1 is there, okay. So what we can do is try to pull it out on metal 3, okay. So now let's, I want to put metal 3, okay. Metal 3 to pull it outside. Okay, I put another metal 3 up a bit. Okay, so now I have metal 3 to metal 1. So what we are, I need to put metal 3 to metal 2 and then metal 2 to metal 1. Okay, so now I have, let's start with metal 3 to metal 1. Metal 3 to metal 2. Okay, I have one here. I put it here. I put it here. Okay, correct. So now I need to put for metal 1 as well. So metal 3 to metal 2 is connected. Now metal 2 to metal 1. So I need to select another metal 2 to metal 1. I put it same on the top. Same on the top. So now metal 3 to 1 is connected. So how it is connected? You have your gate here. So if you look from the side view, okay, you look from the side view, you have your gate, okay, you have your gate, metal 1, okay, gate, and you have the connection just now, which was on the top, metal 3, and I put it on the top, correct or not? Okay, metal 3, this is metal 3. Okay, when I put via, I have one via, which is metal 3 to metal 2. This is called VR2. Okay, and I have another metal here, metal 2 here. metal 2. And the next one I have via 1. So now all these are connected. Can understand? Okay. I connect from the top, metal 3, and going down to metal 1. Okay. And I need to put 2 vias. Okay. So this one is done. My gate is done. So next one at this one, I have okay, so I have this one from this drain to this drain. Okay, so which is from here to here. Okay, so let's test it out. See, from here to here, which is this no, this nets. Okay, this nets I must go to from here to here. So what I do, I just take metal 2. I have no obstacle there, so I just take metal 2. Just draw like this. Then I put metal 2 to metal 1. Take, let's say, 4. That is connected. Okay. So now it's connected. And also here, okay, back. Okay, so another note is this one. So we have drain to gate, okay, and gate to gate at the bottom one. Okay, so this one, I press P and try to connect this one and this one. Done. It's connected. Okay, so but this gate should go to this gate now. Okay, so I can do two things. I can just draw the rectangle like this. Okay, I can even pull the wire and then change it. So let's say I want to pull the wire. Pull the wire, metal 1, and I go up to here. I put first. And then I click on the metal Q, and then I change it to metal 2. Okay, so then I put a via metal 2 to metal 1. Put one via here. I put one via here. Now it's connected. Okay, so gate and gate connected. My drain and drain is connected. So what else is left? So I have this one and this one. It's done. So all of them is connected to here. This one also connected. And only thing left is our capacitor now. Okay. So let's say I want to check this one. T2. Check on the schematic. Is it connected? Yeah, it is already connected. Okay. So from here, here, there. And this one is also connected to the gate. Okay. So we are done on this part. Now from the capacitor. Capacitor now, we have our positive side as the V out, our output, okay, coming out from this net. Okay, so let's find where that net is. So that net is here. Okay, so this is the output net. So let's check where it need to be connected. Okay, it's there. Okay, so metal 5 is to ground. I want to pull my metal 6. So we know metal 6 is the positive of the capacitor. See, so it's showing to there. So let's check the net. This net. Okay, so this net we just connect it to here. Okay, so metal 6 up to here. So how many via I need to put? Okay, so I must make sure it doesn't collide here. Okay, doesn't disturb anything here. So I can just move this one a bit, move it like that, as long my metal 6 is connected. Okay, so I can put via. I need to put from metal 6 to metal 2. So I have metal 6 to metal 5, one via, metal 5 to metal 4, one via, metal 4 to 3, one via, metal 3 to 2, one via. So 4 vias. Okay, so let's start from the top. So I need to go from metal 6 to metal 5. Put 1, and then from metal 5 to metal 4, put 1, and then from metal 4 to metal 3, I put 1. Once you put escape, and then press O again, and then metal 3 to metal 2. Done. So now it's connected from metal 6 to metal 2. We already penetrated down. Okay, so this is just for this software. So for the latest one, you have metal 6, metal 2, right? You just click on the top, it will put automatically for you. Okay, so that's the latest one. Okay, so next one is metal 5. So metal 5, I know it's just from here, the bottom. I just draw metal 5. Let's select our metal 5. Metal 5. Press R, draw the rectangle. It's still coming on that. Need to select metal 5. 5 draw. Okay. Okay. Metal 5 goes where? Metal 5 goes to your ground net. See? To the ground. You just connect it to your ground like this. So now we must go up to metal 1. Metal 5 to 4, 1 via. 4 to 3, 1 via. 3 to 2, 1 via. 2 to 1, 1 via. So we have 4 vias in total. So we do the same. From the top, metal 5 to metal 4. And I have a big one, so I can just put 6 rows, maybe like that. Or even you can put how many you want, 15. Okay, so it's long. 15, metal 4, metal 5 to metal 4, and then metal 4 to metal 3. Okay, and then metal 3 to metal 2. Okay, so and then metal 2 to metal 1. And it's done. So all the connections are connected, and this is where we will use our LVS. Okay, so later once the license is up, you can try it out on okay on January 2nd week, I think January 2nd or first week. Okay, so you can once you draw like this, you can test your layout and schematic whether the connections are correct or not, and also DRC, like how close or how big your metals are. The DRC will check for whether this layout is correct, without error. Then the LVS and DRC will check for it. We missed one, which is our capacitor bulk. Where does the capacitor bulk goes? It goes to ground, correct or not? Okay. So what you can do, you just pull a metal 1. Okay. Let's go to metal 1. Draw a rectangle on it. Metal 1. And I just draw it from here up to here, connected. Okay, so now it's connected. So in order for LVS, one more thing you need to know. Okay, in order to pass LVS, right? Okay, to pass LVS, you must have pins, and text labels. Must have this. If you don't put, your LVS will never pass. Okay, so in order to put that, okay, you can just go here and put the label. Same thing, just press L, create label, right? So we have VN, VP, VDD, and ground. Okay, so let's say my VDD, where's my VDD is? Okay, so my VDD is metal 1 over here, correct, right? So I can put VDD, and then next option. Okay, I cannot change it here. Okay, so I have my VDD here. So press this one, and this metal 1 here, right? So once you put here, drawing, okay, so I think you can change here as well. Before you put label, let's go here. We change it to metal 1 text. Okay, so metal 1 text, then we create the label VDD. Let's check whether it's in text or not. Yeah, TT. Okay, text. Okay, DG is drawing. Okay, just go through all that. So we just pull this, put it here, our VDD, and we have our VN and VP. This is our input, VN and VP. So which one is VN? Is this VN? Yeah, so that's the transistor that goes into VN. So this is VN, and the other one is VP. So I go back to my layer selection window, and I select metal 3 text, and I put my label of VN, VP. Okay. So I cannot put one by one, so I have to put one by one. Okay, so I have to put VN now, and put it on here. Okay, and I have my VP next. Okay, VP. So I have my text VDD, VP, VN, and let's put for ground, which is on metal 1 text. 1 text. Ground. Is it in text? Check. Yeah, seen in text. And we also have our output. So our output is metal 6 from the capacitor top, correct or not? So this is where our output is, V out. Okay. You can go to your layout. Okay. I can draw one from metal 6. Metal 6 top. And I draw the rectangle. And I just pull out. This is my V out. And I put it in text. Put my text, metal 6 text, L, V out. V out. My layout is done. Okay. So this is how you draw the layout. Okay. So this is just very amateur level. So we do it quickly. So when you do like a very professional, it has to be like a very close enough. Okay. Like maybe 1 micro, the spacing. Let's say your DRC spacing between devices is only 1 micro. You only place them 1 micro closer. Because once you tape out, like TSMC 65 nanometer, when you are sending for tape out, 1 mm size is 6,000 USD. Okay, 6,000 USD for 1 mm. So you have to put all your schematic as close as possible to reach it. If you put this far, then you waste more money. Okay. So this is how the drawing scale is. So we are done with our layout. You can try. Okay, all the tools. So this one for your mini project is bonus mark. If you include this in your report, you get 10 marks. Okay. But it's not compulsory. It's up to you. If you don't wish to do it, then don't have to. But if you put that, you get extra 10. Okay, so in more advanced level, like the pin sites, for this PDK, we are using text, the text layers to place the labels. But for TSMC, for Global Foundry, everything gonna be different. For TSMC, we normally use the pin layers, metal 1 pin, metal 2 pin to put the labels. Okay, so it depends on the different PDKs. So that is why whenever you got your PDK, the first thing you do is study the PDK, study the documents, study the components. That's the first thing you do before you design your schematic. Okay, we got 1 hour. You may try to draw. So if any questions, you may ask me. So next week, Mr. Zol will teach you guys theory again. Okay. So I can show you guys example of caliber and LVS. So since I have the license, only the instructors have. Okay. So from caliber here, okay, so you can run DRC. So this is how we run the DRC design rule file. Okay. But you guys cannot do it because you guys don't have the license. Okay. So once you have it, so this is the rule file that we include in the DRC. Okay. So and all I need to do is run DRC. Yes. Okay. So see, so this is the DRC errors. So we have errors there. Okay. So what is this error? So it says here, minimum metal 1 space is 0.23 micrometer. And see or not? So this is how your layout will be checked. So when you click here, it will zoom into the place. See? So the metal 1 space. So let me only show metal 1. 1. Okay, where's the error just now? Can go here. See? So your DRCs cannot have this kind of errors when you design. So that's professional level. For you guys, just learn to draw first, okay? Because you must have this DRC check. So how do we solve this? So we'll just put a rectangle there. Here. Like that. Okay, so then the DRC will disappear. So let's look at the another one. So we have another one here. Here, see? So from here to here. So I just draw it again. Okay. So now you see we have this error, right? Check for 9021. So if I run it again, so that error will be solved, will be gone. So this is how the layout process is. Once you draw and then you run the DRC, check where the error is. Okay. So see, so the previous one is gone. So we have a metal area different 493 now, and we have this, and this. So all of them are showing at different places. Okay. So this is how your DRC check will be done. See? Okay, so this is for metal 3. So it asks to solve us for metal 3. So once you click that, it will zoom into the place and ask you to solve, and you must solve the DRC error. Okay, so that is on DRC. So let's check for LVS. So whether my layout and schematic is same or not. So same thing, we can run LVS. Okay, so you must put in all the rule files, the outputs, inputs, and everything. So run LVS. Let's see whether there is any error or not. Incorrect. So we have something here. Okay, comparison results. Okay, so everything is error. So you cannot put it on ports. Okay, all the ports is missing. So I need to put a pin for it. Okay, so I cannot simply put the text layers. So it doesn't work that way. Okay. So I need to design, generate from source again. Remapping cannot be done. All constraints, all instances, and layout. Refresh. Okay, so this one, update components. Okay, so when you're doing right, so make sure you take this into account. So when you do the layout and you go back to design and generate from source, everything will disappear. Okay, so don't do that from here. So you need to go to here and then update connectivity and update. Okay, so update it. Don't generate from source again. So once you are done the layout, if you generate from source, if you go here, design, generate from source, so you'll get this warning. So it will delete everything. So it will be blank. So don't go there. Okay, so you must go to connectivity to update. So update component and nets. Okay, like this. Okay, and I don't want instances. I want this. I only want my IO pins. Okay, IO pins. I select all as F metal, say metal 1 drawing. Okay. Okay, so these are my pins. Yeah, I must put pins on this. Names, okay. So let's check what this pin is. Okay, so this pin connectivity is ground. So let's change it ground to metal 1. So Okay, and then we put the pin here. The ground here. Okay, put it there. So, and then let's check the connectivity. This is V out. So our V out is metal 6. So we change to metal 6 draw. Okay, bring it to metal 6 here. I put it here to my V out. And then this one is my VP. So my VP is metal 3. 3. Where does it located? So it is located at here. Okay, VP. This one is VN. So VN is metal 3 as well. Change to metal 3. This one will be my VDD. So my VDD is metal 1. Okay, so now let's put it here. Okay, let's test for LVS now. So still got some errors, just not coming. So same, okay. So I have some issue here then. So this is how you will get your report, okay. So let's try to. It. Okay, now it's passed. Hey, no, still no. No, it's not compared at all. Okay, you guys can continue on the drawing part. Okay, so let me check the issue here.
这边再讲一个，要我先不少，这个反正这个最还是比较比较如果你有这个也是越爽。现在后出现没有办法算这个赛是很好的，可以的，是这个已经到这个感哦，这个也差不多还很久。它有这样放大的那个用的它们都很有那个一些上面而且我们影响这个其实是到这个这个回到像是一个就是发生是有在那个海洋这里面跟我们来有个感觉所以我说也还也很上这个可以直接影响就是可以就是有我们好像那么一次就是会是那一次跟您再给跟你发那个看到一些这上一个就是另一个或者是像问题现在就是那种另一个是那个另一个那就是
Yeah.
Oh, it's a way that if we accidentally quit this whole cadence, then I already quit, I reopen already, but I unable to edit. They will say that
Oh, okay. Good. Yes, yes.
why?
Good, yes. Because it's your file is locked.
Okay. So I only
Go to design, make editable. Click. Now you edit. And right. Pull this one.
Oh,
Because you want to edit, right?
oh.
Can edit, right? Yeah.
But why I still cannot like run chat or save things started?
Okay, that one you need to go to your file.
Okay.
Press your file browser. That. Another one. Go into the go into your library. Go into your library. Remove open. Yeah. So which file is that one? Open. Yeah. Go to schematic. So you see this serious log, right?
Oh, this is locked.
It's already locked, so you delete that one. Okay. Okay. Now try again. Your schematic.
I reopen.
Can reopen, can refresh. Try reopen.
Oh, nice.
Yeah.
Thank
So
you.
that's-
Earlier, just now the layout that we need to setting on, I forgot what's the start display level that
32.
34. Other than this, is there anything I missed? Like the VP name,
Yeah, all correct.
just like that, then try. Thank you.
All right.
这样你就得到了这样一部分这个完全用它预设的是这个你听到
有两个是就大的这边的规则是不上特别条件，什么你可以这种故事，不知道这个费用是反正是然后当时的话，王平其实没有想要看是上面是之前这个然后全部就是给他打了这个这个你们发情况，那因为一个美国的就说是通过这种情况做出来一个这样的就差不多我不是拿这个样子。你把那个这个东西，好吧？现在是就是对那个。然后这是在当回台湾法律的人所谓的那这是跟是来，就不用死一个把它加掉，所以看已经都是我所以我们设置的是按情况下原始的任务的这个对于可以，我觉得主要是反正我呢，我不想在这里学到的，是因为有那个方法，然后要特别，进行应该就是这个对吧？可能像你刚才说的那个新的设备，那当时就是也是就是你刚刚说的那个，就是那个是这个艺术的，没有找，没有地方，我不打，我发现反正睡觉如果那种话，就是要加稳加死的，应该是话那就是不是我说刚才那种的一个带着这个，我有那从那个我传达是那种上司配的。这个是把这个专业是哪个地方的？这个话这个出来这个是哪个方面当时这个应该也是说没有是一个比较小线上的，有的他说洗车费用或者是老司机赶紧这就引导专业。我也真有去带了不是那种接的这个啊，对，
you. I do what happened? Oh,
For FIP, is it?
ah,
For FIP or what? Oh,
my就是我的就是用了
哦，
my
You are
supervisor.
yeah, research supervisor.
Okay, okay.
You are the research supervisor. Yeah, meeting is it? Schedule meeting.
what's up
Yeah, then create a group for
yeah, what's that?
You need your
Yeah.
WhatsApp number.
016.
Oh, it's not home.
这儿就可以，这就可以讲。
Oh, I think
哦，我把你俩拉进
in the group chat.
Yeah, got in the group, right? Yeah. The link I put also, that's my number.
I choose analog IC or digital IC
So you have your own title or what? You want own title or you want me to give title?
He's more interested in digital, I think.
Digital IC.
Oh,
Okay. So what title you can propose?
什么题你有想法吗？
Your own title.
这个还
temporarily no.
Okay, so maybe you can go and find something and then come and give
I
me
use FPGA before.
FPGA, but here not much.
I don't know digital IC very much.
Okay, okay. Okay, so maybe I try to come up with a topic.
Oh,
老师会讲这个再可以。
okay, okay.
Okay, all right.
我分到的是数学老师。
I invited you to into the group.
Yeah, sure. Okay, okay.
Thank you.
我记得他很爽，那个也是很高兴，题目都自己去，对，影响不一样。问题了，不然那个做是有我说我在专业发的，两岁人直接做什么这个是有发的，还是做我的评估是对的。就没什么，只要做模拟，它就是要在做养胃做完了第一份，我就做一个，可以。他说我创业是还在看，但是如果有你的想法，你可以跟他好的。像那些改变，没办法去分的，这是我你还是这样，设这个那你们跟我们的民创确实。我这个这点是办法，就是那个就是两个，就是我就是它多了一点那个东西，多了就是大学的第一个嘛。是的，我们那个超级难。没有看了一半。你那个。你那个周围在这里，更加的复杂化，真的吗？我用的不是大的，别想太复杂，它会被掉的。这个是别的，你要问一下那种，这个问一下，就是什么？所以其实我有一点。
Yeah.
There is a
Safe.
I don't know. Tell me there is no response. So it should be from
你是说，就是他的意思问还是会讲一下，就比如说10年的以前有些反应，这是
没有错误，
对，
是警告还是说？我也有，我第一回做没有，这回对。
This one should be input output.
，yes，已经改到
This one is output.
我之前没听过有这个，
是这没连上，不是它那个参数语它是音
然后就是这样，是把那个定量变成你可以然后别说不写以后，它数据里面可以是
比如我们还有 B 所在的地方，还有 BC 和 DC 给它加个仿，给它加个风，就是仿的服装的角色。
可能他还会教你就是什么，
我并不说你这个 traffic 的话，就老是非常觉得没有叫做他都没教你怎么，他就能懂，有没有研究一下？是 the facts，不会一年你想的你能学过？你要说的肯定我觉得不可能。
那这个的微信准备。
懂吗？太早啊，太多了，不赚钱啊。对方
您说一下讲的是，有个报错，那个参数没调对，那个就是报错。
是在李梦得到的 USF。我们真正也没有很多时间，我们以为我们现在买就是有2个月可以做，但是他说其实我们好像就3个月就可以做，然后3个月过后我们就要开始交论文，然后我们就还是他还有什么？还有就是在经营的方面，我就听到这样子，
那个就是要我们，你说的那个第一次，他那个对象这个最高，
然后就不要想的太
Still something wrong.
你忘了上次被练
哦，对那个这个是在后面的 validation 就是我们有那个兴趣去，然后他在那个来，然后下一个很多那个stress test，但他其实 fail，他 fail 了过后我还要去等他，为什么？
我知道哦，就上班把程序，
有200多架，我要。
就是在，
然后我再收数据，
就是在我们那边做的一个就是社区平台下面是他这个是在那，他非部的现在都是在就是
Try doing a symbol.
对面，
Try doing a symbol. I think it's kind of bug. So it cannot detect.
它不是冰山，它算是击打着
White warnings, but this one is just warning. You can ignore. Try to simulate whether you can get the output or not. If you get the output, then it shouldn't be a problem. Still okay.
就不用管了，他也搞不了。
或者是个警报，
但是你肯定不用管，这就没有对管。
我见他，那些那个把那个现在规则，然后把那个问题删掉，并且一个人就是一个骂这个东西的时候，你得把那个今天参数给改，就第二条一共就。允许非常不会的，你那你想的是不是？概括怎么说？关了一次，你的是你看我的这个，我是知道你方面还是哪一种啊？第二，你把 VM 给封了，封了一个啊。
所以会给这个啊，对对，然后就
啊，对对，还有感觉的这个，就经历了200，然后上面那3个月，那我这315我还有4个车，4个点。这样是吧？哦，你是改那个 P。
跟年，
我已经找不到了。找不着，另外呢？无论单独分析做一些使用条件什么的，然后中高的意思，那全部是中文的，我也有这样的理解。你把这个图撕出来，这个就是正常的方向，它就发现 我那边没上上楼的，这个你没有装，就是我把它缩小。找到那个地方，它可能在别处，你得缩小它给你放大。我缩小，我比较人手了。我们的卡通片，那个是确实。
I cannot find it. I smell it and cannot find it.
Which one is first? This one for?
Oh.
Just F3. I think you zoom. If you zoom too much, it's like a well, so F3. Okay.
这个今天你选动物，你这个间地这个你不是要求一样的，然后改这个改六派嘛，这个只要改成那个第是个 P， 这个 P， 对，你看我的中药来，你指这个了，对。就是一个。有点像一个这里面是一个点，我知道他们什么都是这个。这他们改那个什么多少，就是表的有些非常那个，就是不是这里面什么其他这里面的这个里面其实我们只有这个听这点的什么没有，它不是个里边，反正就是一个里面3点。还是读3点，有点分的时候，不是20个人都不会回到原图上来，原图上打不完，原图上它就是个这个。因为这里啊，那你再打开那个文件再改，对啊，就改啊。这它本身的4点是是吧？好，这么可能。还有2个系统，那个练习方面那个领域，你是打去不了那个对的里面去不了这个要把这个东西要对这个要。啊，把这个改成平行。对，这个要改成。就是好像是一个点，然后从中间慢慢这个地址，那这个你要改成这个是英文的背后，第三个然后还有一个人我觉得很明显，所以我应该是这样，是不是毕业他们是也是然后大家就说好，你那经济感发现对不对？就进去了，都反了，然后现在就非常不是，然后然后国内边国内这个回来之后，把中国这表现一下，我给你讲。非常棒的，你知道吗？我感觉你也很好的。你知道吗？我得其实2年的时间，对方的话，我是说，对方可以保持化妆的班少，你好像没问题。阶级警告了啊！我看到就是现在是给你广一点本科生硕士，他会建议他们优化了。你说聘的时候拍这个，然后就被扣这块直接感觉到是聘啊，就听他这个说啊，这你可以对吧？那样的话，VTGV 那些都是都是老师，你们总是要这玩意儿你们去看，但是我对这个就是他能听到3分钟，对，就是简单，我给你没有要这个，先让我们我们其实
Okay, so when your LVS is passed, so this is how you will get it correct. So your layout and your LVS is correct. Okay, so this is your schematic and this is your layout. Okay, and all the connections are correct and will be defined by your LVS. Okay, so if it's not correct, like just now, so it was actually the setting in the rule file was wrong, so it wasn't the correct process option. So when you select the correct process option, then your LVS passes. Okay. So that's all for this lab today, for this week. Okay, so next week, Mr. Zol will be teaching you guys. So I'm only 2 labs for you. Then we are done. So I guess that's all for today. Any questions? Mini project or anything? Okay, so make sure all the reports are correct and all the specifications, all the requirements are met in the report. Okay, so if you are capable to do the layout, then you will get some additional marks. Okay. Okay, we got 10 minutes more for the class. Yeah, that like the last lesson. Whatever we did in the lesson, right? So all the plots. So and then same plots you just include in the mini project, but make sure you achieve the specification. Example, our lab was 40 dB, right? But your mini project was at 50 dB. So you must show it's 50 dB.
And the
That one is just additional knowledge for you. It's just a skill method for you. Okay. Yeah, only the layout is bonus 10 marks if you're able to do it. Okay. So let's say your report is you lose mark here and there, but then I see you got your layout, and then I just add up for you like that because the mini report is 100 marks.
so will be okay. I see.
So let's say your report is like you do everything and you get 70 marks, but then you do your layout. So based on your layout, I give you 10 marks. So you get 80 like that. Understand or not? So this is more like bonus if you're capable.
It's not compulsory.
Not compulsory. If you don't want to do, then it's okay. Okay, as long as you meet all the report requirements, then it's okay.
Thank you.
So which chapters will be tested?
This one who's teaching? So
Common source and clear. So
this one Dr. Jaga, is it?
this, so this,
Common source is 3.2.
2,
Yeah,
2.
common source. Common source, right? Where's the message? Yeah, common source. So it's 3.2. This one.
Just the 3.2.
Yeah, just focus that.
But after I set the specific the layout spec,
That's right.
then I want to click which things to add the like just now all the module that
All the components.
ah
So then you go to this one is layout, right?
layout.
So this is layout.
Maybe I
Sorry, this one. So note, then design. Now this one is what? This one is layout, right? Open for the layout. Okay. So you should have generate from source actually.
I click E.
No, this is something wrong. This is make editable.
Oh, again the thing.
Yeah, again the thing of what?
But I already delete the log.
Yeah. So because you deleted it in there, this one is what? Open, right?
This one got me.
So op-amp is correct. You deleted in the schematic, right? Schematic is done, but you have your master layout. There's no layout.
Oh yeah, I want to say the layout they save at outside one. Why?
Oh, that one you need to invoke from here. Where's your layout? Just now?
If this is like my layout, I already.
It's already here. No need. So you just from here, tools, and then
Okay. Design scale.
just go to tools, design synthesis, layout.
Yeah, that I create new. But why they choose my library Raymond then?
Raymond op-amp, right?
Ah.
The style name is op-amp. Don't change the.
Oh, don't change this.
Yeah,
Ah.
don't change it. Just like that.
Ah,
So don't change anything on that. So now you design, generate from source.
Oh.
Yeah, left of this suggestion not need for now.
Not me.
Yeah.
Oh, okay, okay. Oh,
Okay. So do the settings for all the components for the bulk settings and all. So later just watch the video.
Yeah.
Okay.
thank you.
Okay guys, so we are done. All the best with your mini projects.